Hello everyone, today we're going to be going over question 2 from paper 2 of the sample assessment material for IGCSE Quadratic in Mathematics, the Edexcel board. Alright, so this question is about topic 3, Identities and Inequalities, and it is asking us to find the set of values for which this inequality is true, and this inequality is true, and then both of them are true, so values which satisfy the requirements of both of them. Alright, so for part A, we can simply solve it like we would a simple linear equation. So subtract x from both sides, and add 1 to both sides, and you get x must be greater than 4. Then for part B, this has two x terms being multiplied together. This is x times x minus 1 must be greater than 6. So we will expand this bracket out to get x squared minus x must be greater than 6. Subtract 6 from both sides to get x squared minus x minus 6 must be greater than 0. We can solve this, we can factor out this quadratic from the fact that the two numbers that we factor it to must multiply to negative 6, and then the sum of these two numbers must be minus 1, so these two numbers are likely to be 2 and negative 3. And yep, this works because 2 times minus 3 minus 6, and then 2 plus minus 3 is minus 1. So we have x plus 2 times x minus 3 greater than 0. And then we can draw a little sketch of a graph here. And since we know that it will cross the x-axis at x plus 2 equals 0, so x equals negative 2. And then we'll also cross the axis at x minus 3 equals 0, x equals 3. So here this is minus 2, and here this is 3. And since the coefficient of the x squared term is positive, it will look something like this. Now, we want the values of x where it is strictly greater than 0. So everything on this side, which is strictly past the minus 2, and then everything on this side, which is strictly past the minus 3. So x must be strictly less than negative 2 and strictly more than negative 3. Or x must be more than positive 3. My bad, I have misspoken. Alright, so if we want to find out what satisfies both of these inequalities, we can use the calculation method, which is not really a calculation, it's just what I like to call it, and essentially you plot both of the inequalities as if there were an invisible number line. So you have must be greater than 4, and then you have must be greater than 3, and must be less than negative 2. And if you kind of add them up, you're looking for what numbers satisfy both of these. Alright, so if you try a number below negative 2, it only satisfies this one, so this is not valid. In the middle, it is not valid because neither inequality is satisfied. And then between 3 and 4, only the bottom inequality is satisfied, until you're left with the fact that only the numbers greater than 4 will satisfy both of these inequalities. So you end up with this statement only. X must be strictly greater than negative 4. Alright, let's look to the mark scheme and see what we got correct. I've had a peek at some of the other questions in this paper, and they're quite challenging and interesting to solve, especially in the last one, because it is an 11-mark single part question, which I'm quite thrilled to undertake. It's about the volume of a code that keeps increasing over time, but I'll cover that later. So here we are at the mark scheme. 3 plus x is less than 2x minus 1, so x must be greater than 4. Yep. X times x minus 1 is greater than 6, so this quadratic must be greater than 0. And if we factor it out, and we find through graphing these two inequalities. Yep. And x must be greater than 3, or x must be less than negative 2, and x must be greater than x must be greater than 4. So x can only be greater than 4. Yep. So 5 marks. Correct. Thank you for watching. Have a great time in here.